The most important thing about the law of cosines, and as we go on here in this chapter, the law of sines, is going to be the terminology, the labeling of our triangles. And now, again, we kind of talked about this yesterday. How many parts are there to a triangle? 6 parts. There's three sides and 3 angles. The 3 angles, or the 3 vertices of the triangle, are going to be labeled with capital letters. So we could call this down here triangle A, B, C. And now really ultimately does it matter where we put the A, the B, or the C? Could they go on any of the 3 vertices? Yeah, absolutely they could go on any of the 3 vertices. But then we've got the sides as well. So we're using capital letters to denote the angles. We're going to use what kind of letters for the sides? Lowercase letters for the sides. Now, side A. Where are we going to find side A? Yeah, it's side BC. We find side A opposite of angle A. So this is angle A right here. So the side opposite of angle A is going to be side little a. Where would side C be? Between the vertices A and B. This over here would be side C. So angle C, opposite of angle C is side C. And then opposite of angle B would be side B. So it's very important that we can properly label our triangle. We use the capital letters again for what? The angles or the vertices, lowercase letters for the side. Side A is found across from angle A. Side B is found across from angle B. Side C is found across from side C. Okay? This labeling is very important because the labeling of our law of sines and law of cosines uses this terminology. So the capital letters represent the vertices or the angles. The lowercase letters are the corresponding sides found across from their respective angles. So angle A or vertex A, opposite of it, side A. Okay with the labeling of the triangles? That's first and foremost. We're not going to be able to understand or apply the law of sines or cosines without this understanding. Capitals are the vertices. The corresponding lowercase letters are found opposite, and they represent the sides. Okay? So then the law of cosines from yesterday in your video, which is basically described as the Pythagorean theorem for all triangles. Again, Pythagorean theorem only works in right triangles. Well, there's a lot of triangles that are not right triangles. How can we find sides on those? Well, we can use the law of cosines. The law of cosines, though, it's very important that we, again, have a side, angle, side setup. Side, angle, side. Now, that means we've got 2 sides. In which angle specifically? Why do we put it in between the 2 sides? Because that angle has to be in between the 2 sides. So a side, angle, side scenario. Okay, so given 2 sides and the included angle, you can find the remaining side. A squared is equal to what? B squared plus C squared minus 2BC cosine of angle A. If we're looking for side A, then we need to know BC and side A, or angle A. What would B squared be equal to? A squared plus C squared minus 2BC cosine angle, I'm sorry, not A, angle B. Yep, if we're looking for side B, then we've got to know angle B. And then the last one down here, C squared, what would C squared be equal to? A squared plus B squared. Yep. Yep, we've got side A and C, so we need cosine AC right there. Yes, you're correct. Minus 2, and this last one then, C squared is equal to A squared plus B squared minus 2 AB cosine capital C. Okay. Now there's a couple different operations that are going on here in this formula. We've got squaring, we've got addition, we've got subtraction, we've got multiplication. Which parts need to be done first? We've got to square first, then the addition, subtraction, or multiplication. Then the multiplication, then the addition, and then the subtraction. So you've got to be very careful to follow your order of operations here. And now ultimately, They're not solving this for side A, B, or C. They get A squared, B squared, and C squared. So how do you get side A then? You're gonna get this solved down. You're gonna say that A squared is equal to something, and then you're gonna have to take the square root of both sides. Okay. So any questions on the formula for the law of cosines? Okay. Just like with our probability formula here, we will always write the formula, then substitute and solve. Okay. There is going to be a step-by-step procedure on all these triangle problems that you need to go through. So you've got a triangle RST. Does it matter that it's not ABC? No, we can have any three letters representing the vertices. They're telling me that side R is 12, S is 11, the measurement angle T is 120. They want me to find side T. Well, what's really the first thing I need to do here? We need to draw and label this triangle. Okay, so here's a triangle. This is going to be triangle RST. Does it matter where we put the R, the S, and the T? Absolutely not. So I'm going to call this one up here R, over here S, and T, clockwise around, RST. So where would little r be? Between S and T. So here's little r, which we know is 12. Where is little s? Between r and T is little s, and we know that that's 11. Right here is angle T. We know that that's 120 degrees, and we want to find side T over here. So do I have a well-labeled triangle? Yep, I've got all my vertices and the sides labeled with the capital letters and the lowercase letters respectively, and I have marked what I know. So do I have a side angle side setup? Yes, I have the two sides, R and S, and the angle between them at T at 120. So can we use the law of cosines? Yep, so this right here is step one, well-labeled diagram. Well-labeled diagram. You're not going to be able to determine if you're going to be able to use law of sines or law of cosines unless we have a well-labeled diagram to see that we have the side angle side scenario that we need. So once I determine that yes, I can use law of cosines, step number 2 is then to write the appropriate law of cosines. Now which side are we looking for? So what will we have here? T squared equals R squared plus S squared minus 2RS, and we need the cosine of angle T. So step number 2 is the appropriate formula for the side that we need to solve. Step number 3 will then be to do what? Substitute the values we know. T squared is going to be equal to, and we always substitute with parentheses 12 squared plus parentheses 11 squared minus 2 parentheses 12 parentheses 11 cosine parentheses 120. And now that we've substituted in, we just need to do what? We just need to evaluate it. Now where are we going to go to evaluate it? So it's very important that we're in a very specific mode here in our calculator. This is a trig problem. What mode do we need to be in, and why? Degrees? Why? Because they said here 120 degrees. Okay, so we need to make sure that we are in degree mode in the calculator. Okay? So that's the first thing we're going to check. Mine's in radian, so I need to come down and change it to degree mode. And then back to my home screen. Okay? And what we're going to do then is type exactly what we have written in here. We have parentheses 12, close squared, plus parentheses 11, close squared, minus 2, parentheses 12, close open 11, close cosine. They already opened the cosine for us, 120. Okay. So do I have typed in exactly what we need? Yep, 12 squared plus 11 squared minus 2 times 12 times 11 times the cosine of 120, and I get 397. Now that 397 is equal to what? T squared. t squared equals 397. So therefore, t is the square root of 397. Now, normally, folks, when we undo a square, when we take the square root of both sides, how many square roots does every positive real number have? 2. One being positive and the other being negative. Now, we've got to be smarter than that, though, here and say that t represents what? A side of a triangle. Can a side of a triangle be negative? So we're only looking for the principal or the primary square root. So to the nearest tenth, then, we're going to take the square root of this 397, and to the nearest tenth we get what? 19.9. So t equals 19.9. They didn't give us any units up here, so we're just going to say 19.9 units. So we're going to come up here and label the triangle then. T is 19.9. And now we've got to ask ourselves, bless you, is this reasonable? Does it make sense? We just found out that T is the what side of the triangle? It's the longest. Yeah, it's longer than either of those other two they've given me. Well, if it's the longest side, then that means it's got to be opposite of the largest angle. Well, can I have an angle larger than 120? No, I can't. Not in that triangle. There can only be one obtuse angle. So is it reasonable? Yes, it is. Okay, so step number 1 will always be a well-labeled diagram. Step number 2 will be the formula appropriate to our situation. Substitute, solve, and check for reasonableness. Make sure that, if it's the largest side, then you're opposite the largest angle. If it's the smallest side, make sure you're opposite of the smallest angle, so on and so forth. But always check your reasonableness. Big thing here that I have to take off points for on the Regents exam is being in the wrong what? Being in the wrong mode. If you're in radian, watch what happens. So let me turn this back to radian mode. So now I'm not taking the cosine of 120 degrees, but I'm taking the cosine of 120 radian. Now a full circle is only how many radian? 2 pi, which is 6 1/4 roughly. So 6 1/4 radian is a full circle. I've got 120 radian. That's going around the circle a lot. Okay? And instead of 397, we get 50. And then when we take the square root of that, we would get 7.0, or 7.1. Now, should that then throw a red flag up? Yeah, because you're opposite of a 120 degree angle. Well, this 7.1 would end up being the smallest side. Well, can the smallest side be opposite of a 120 degree angle? Couldn't be. Okay, so you've got to make sure that you are in the correct mode. Now, what I just did there, is that a half credit conceptual error or just a 1-point arithmetic error? It's a half credit conceptual error. Whenever you're dealing with trig, you need to know what mode you're supposed to be in. If we've got the degrees, we need to be in degrees. Questions on using this at all, folks? Okay, again, it's a 4-step process. You are going to show me a well-labeled diagram, a formula appropriate with substitutions, and then solve it out through. Okay? Now, looking at this law of cosines, though, it can be used in one of 2 ways. Number 1 is if we have the 2 sides in the included angle, we can find the remaining side. But, folks, let's take a look at our formula here. We have 1, 2, 3, 4 variables. Well, if I know any combination of how many of them, 3, I can find the 4th. So here we knew these 2 sides in the included angle, so we were able to find this other side. But what if we know all 3 sides? What would we be able to do if we knew all 3 sides? We'd be able to find the angle. And that's what I've got here on this slide, is if we know all 3 sides, we can find any angle. So the law of cosines can be used to find sides and angles. Okay? And what I'm going to do here is I'm going to rework this formula to solve it for cosine A. Now, it's not going to be a variation that we have to memorize. We can always go back to this, but it is a little more useful if we can. Okay, so I've got to solve this for cosine A. All that I want left on this side is cosine A. So how do I get rid of my b squared and my c squared? We've got to subtract them off. So from the a squared that's already over here, we're going to subtract off a b squared, and then we're going to subtract off a c squared. And then what's going to be left over here when I move these two? Yeah, and it's not a subtraction anymore, it's just a negative. Negative 2bc cosine A. Well, what are the operations that are going on over here now then? There's no adding. There's only multiplication. It's negative 2 times b times c times the cosine. So how do we undo multiplication? With division. And what do I need to divide this side by to just be left with my cosine A? Negative 2bc. I'm going to divide both sides by negative 2bc. So over here, the negative 2's, the b's, and the c's cancel out, leaving me only with cosine of angle A being equal to a squared minus b squared minus c squared divided by, bless you, negative 2bc. Now, folks, is that still the law of cosines? Yes, absolutely. It's still the law of cosines. It's just been revamped to be able to solve for a what? To be able to solve for an angle as opposed to being able to solve for a side. Okay? Do you need to memorize this variation of the law of cosines? No, because you can always plug it into here and just solve for cosine A. But does this make it more useful and a little easier? Yes. Now, what are the other ones as well? What if we wanted to solve for angle B? What would cosine of angle B be equal to? So take a look up here. Up here we wanted to solve for angle A. So what was the first side we had up here? So if we want to solve for angle B, then we need to start with b squared minus a squared minus c squared divided by negative 2ac. Or that cosine C would be equal to c squared minus a squared minus b squared divided by negative 2ab. Folks, it is still the law of cosines. We've just solved it for a different variable. Okay. So, folks, this will give us cosine A. How will we actually find the angle then? So we'll solve this down. We'll get something like this. Cosine A equals 0.8421. We'll get something like that. How will we then find angle A? We'll go inverse cosine. So A is equal to inverse cosine of that 0.8421, and we'll find then the measure of angle A. Okay? So law of cosines can be used to find a side and an angle. Let's take a look here at finding an angle. Find the largest angle in a triangle with sides of 6, 7, and 12. First of all, will sides 6, 7, and 12 work? Do you recall from last year in geometry the triangle inequality? Triangle inequality states that the sum of any two sides of a triangle has to be what in relation to the third? Greater than. Greater than. So what's 6 plus 7? Is 13 greater than 12? What's 6 plus 12? Is 18 greater than 7? What's 7 plus 12? Is 19 greater than 6? So can these three sides work as a triangle? Yes. Triangle inequality verifies it. The sum of any two sides has got to be greater than the third. Okay? So what are we going to start off with here again? Well, labeled diagram. So here's a triangle. Did they tell me how to label it, though? No. So can I label it anything I want? What's the easiest way? So I'm going to call this vertex A, vertex B, vertex C. Where's side A? Across from angle A. Side B, side C. Does it matter which lengths I put on the A, the B, or the C? No, it doesn't. So I'm going to go right in order. A at 6, B at 7, C at 12. Folks, ultimately that does not matter. If they don't tell you how to label it whatever you want and put the sides wherever you want. Do I now have a well-labeled diagram? Yes. Now, they want me to find which angle? The largest angle. So according to our diagram, which angle would that be? They want me to find the measure of angle C. Okay, so step 1 is taken care of. We have a well-labeled diagram. Step 2 is a formula. Which angle do we want to find? So we want to find the cosine of angle C, and we know that that's going to be equal to C squared minus A squared minus B squared divided by -2 AB. So we've got a formula appropriate to our scenario. We'll go ahead and we'll substitute in, and we'll find out that the cosine of angle C is going to be equal to parentheses 12 squared minus parentheses 6 squared minus parentheses 7 squared divided by -2 parentheses 6 parentheses 7. Now I will caution you to do this in 2 steps. When I go to the calculator, I'm going to do the top. So I'm going to go parentheses 12 squared minus parentheses 6 squared minus parentheses 7 squared, and I'm going to evaluate the top, 59. And now I'm going to divide that by parentheses, -2, parentheses 6, parentheses 7, close the whole quantity off. And we get that right there. Okay, so let's say cosine C, what is it, -0.70238 ... So now what do we have to do and show? Because it's a very important step here, folks. C is equal to inverse cosine of -0.70238 ... Okay, so in the calculator now then we're going to go second cosine, second answer. And we get to the nearest degree, what? 135 to the nearest degree. So C equals 135 degrees. Does that seem reasonable? Yes. We know that C is the largest side, so this has to be the largest angle. Could there possibly be an angle larger than 135 in a triangle? Absolutely not. Absolutely not. Now again, though, I asked you, do you have to memorize this variation of the law of cosines? Absolutely not. Watch this. We want to find angle C, so we could say C squared equals A squared plus B squared minus 2AB cosine C. So we would say over here 12 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 cosine C. But you've got to be very careful at this point now then, folks. What's 12 squared? 144. I'm going to go ahead and add these two together. So 36 and 49 is 85. Minus 12 times 7 is 84 cosine C. But here's the big mistake then, folks. We're going to say 85 minus 84 is 1 cosine C. Folks, can I do that? Why can I not do that? They are not what? They're not like terms. This cosine C is like having an x. Can I take 84x from 85? No, they're not like terms. I cannot do that, folks. I cannot subtract these because they are not like terms. What do we have to do then to the 85? we've got to subtract it across, so 144 minus 85 is going to be the negative 84 cosine C, and then we divide by what? So cosine C is going to be the 144 minus 85 divided by negative 84. And are we going to get this same value up here? Yes, we are. Okay. So you don't need to memorize this second variation of the law of cosines, but folks, will it make your life a little easier? Yes, it'll make your life a little bit easier if you know both variations of the law of cosines. Ultimately, you don't need to. You definitely need to know this one. And from this one, you can get this one. But when you're solving for an angle, it's a lot easier to be able to start right here at this one, where cosine C is C squared minus A squared minus B squared over negative 2BC, AB. Okay. Questions with the law of cosines? Either variation of it? Okay, so if we know two sides of the included angle, we can find the third side. If we know all three sides, we can find the angle. Okay, now folks, sometimes instead of telling me that angle T is 120, they might come right out and say that cosine T equals, that's a 60 degree, cosine of a 60 is, they might say that right there. And then, when I come to my formula, then I just simply replace cosine T with negative 1/2. It's not cosine negative 1/2. The whole thing gets replaced with negative 1/2. I'd like to find one of those in your homework and show you that example. So here's the two assignments then. Page 819 is just law of cosines to find a side. And then 824 is law of cosines to find the angles. Okay. So up here you're using the A squared equals formula. Down here you're using the cosine A equals formula. What do I need to see on all of these problems? Well-labeled diagram, appropriate formula, substituting with parentheses, and then solve it down. Make sure you've got those four things on all of your assignments. Okay? Let me take you to one of your assignments here, and I want to look at one where we're going to substitute all of cosine A in as opposed to 6. 6 right here on page 819. So what's the first thing we're doing here again, folks? Well-labeled diagram. They did call this triangle specifically ABC, so one of your vertices is A, B, and C. It doesn't matter how, though. And then side A, side B, and side C. They told me side A is 10, side C is 7, and they didn't tell me angle B, but they said cosine B equals 1/5. And we need to find side B. So do we have the side angle side set up? Yes. Do we now have a well-labeled diagram? Yes. So what will be the formula for law of cosines to find side B squared for me then? A squared plus C squared minus 2AC cosine of angle B. Well-labeled diagram, formula appropriate to our scenario. And now substituting with parentheses, B squared is going to be equal to parentheses 10 squared plus parentheses 7 squared minus 2 parentheses 10 parentheses 7. Okay, and now, what are we going to replace cosine B with? Completely 1/5 or cosine 1/5? Completely 1/5. They said cosine B is equal to what? So I'm going to replace cosine B with 1/5. And now we go where? Calculator. Now in this case here, does it matter if we're in degree or radian? No, it doesn't matter because we don't have an angle. We know the cosine of the angle. So we're going to type in exactly what we have. Parentheses 10 squared plus parentheses 7 squared minus 2 parentheses 10, close open 7, and then parentheses 1/5. Now, folks, when you go to your calculator, can you do some of this in your head? I would not encourage it, but you could go in and say 100 plus 49 minus 20 times 7 times 1/5. You can do that. I wouldn't recommend it. I would recommend typing in exactly as you wrote it. So we find b squared is equal to? B squared equals 121. Therefore, b is equal to exactly 11. So b is exactly 11. So, folks, if they don't tell you the angle, if they just tell you the cosine of the angle, then make sure you replace that whole fraction or decimal with that value you've got in there. Questions at all on the law of cosines? A very useful formula for us, folks. It's basically a Pythagorean theorem for any kind of a triangle. B squared equals A squared plus C squared minus 2AC cosine B. Or, again, tell me what cosine A would be equal to. A squared, if you're finding angle A, you've got to start with side A. A squared minus B squared minus C squared divided by negative 2BC. And that will find cosine A, and then you inverse cosine to find the measure of the angle. Okay. Again, folks,